Recall that the evaporator and condenser coils provide cooling and heating to a building. The refrigerant flows inside these coils. Heat is transferred from the refrigerant to the air as it flows over the coils. Evaporator coils are installed vertically or slanted like a V-shape in the RTU. Evaporator coils are always found above the blower motor or behind the dampers. Condenser coils are generally present on the outer side of the RTU. Condenser coils come in all different types, shapes, and sizes. Recall an electric motor is a machine that consumes electricity to provide mechanical rotation. The main types of electric motors are AC motors and DC motors. We mainly use an induction motor to drive the blower. It is a type of an AC motor. The motors are connected to the blower fan using different drives. Recall that a blower wheel has blades that are specifically designed to push air into conditioned spaces. The types of drives used in RTU fans are belt drives and direct drives. A direct drive motor is connected directly to the blower on the same shaft. A belt drive motor is connected to the blower with a belt. RTUs generally have two motors. One motor for indoor air supply and another for cooling condenser coils. We don't inspect for direct drive motors, and it needs troubleshooting for any problem. We first need to check for signs of corrosion and overheating. Any discoloration of motor assembly parts is a sign of corrosion. As soon as it is switched off, we need to touch the outer case of the motor to look for overheating of the motor. Overheating of the motor may be caused due to the following reasons. Wrong voltage supply. Lack of ventilation, wrong motor for the unit, or overload on the motor. All of these problems call for further troubleshooting of the complete unit. Recall that relays are switches that open and close circuits electronically. They control the working of a motor. During maintenance, ensure that the relays and contacts are dust-free. It is good to clean the terminals with a brush after switching off the unit. Recall that relay and contactors are checked using a multimeter. We will check the relay if the system is not working. This is a part of troubleshooting the unit. When connected to the relay terminals, the multimeter shows OL, open loop, or 1 when the relay is faulty, else, it should show some voltage. Some of the processes while inspecting the motor assembly in an RTU include checking for belt tension, checking for belt wear and tear, checking the pulley alignment, and checking the motor base and support. In most RTUs, the motor and blower fan is connected via a belt. The belt is connected to the motor and rotates the blower fan. The condition of the belt decides if the motor can turn the fan blades. A tight belt will damage the motor, and a loose belt will not rotate the fan. Recall that a belt is a loop of flexible material used to connect two rotating shafts. There are two major types of belts, V-belts and synchronous belts. V-belts are the most basic belts used in RTUs. Use a belt tensioner gauge to check the tension in the belts. A belt tensioner gauge is a tool to check how much the belt moves when a small amount of force is applied. The movement has to be within limits as prescribed in the owner's manual. Recall that lubrication is a process to reduce friction between two moving parts. Friction is the resistance to motion of between moving objects. Oil and grease are the most common substances used for lubrication. We apply oil or grease to the bearings. We need to lubricate all the bearings in the RTU. These include the motor bearings, motor shaft, blower bearings, and bearing housing. Bearing housing is the outer part that provides support and connects the bearings to the RTU's body. Look for oil stains around the compressor. If there is an oil stain, it means that there is a refrigerant leak and troubleshooting might be needed. Recall that to check refrigerant pressures, we use a manifold gauge. While checking, we need to make sure that the manifold gauge valves are closed. We connect the blue hose to the high side and the red hose to the low side of the unit. If the pressure readings are too low, this means that the coil may have a refrigerant leak somewhere. We have to find the leak and repair it. There can also be other reasons for a low pressure reading. Thorough troubleshooting might be needed to find the actual reason. If the pressure reading compared to the manufacturer's reading is too high, the condensing unit might be dirty. We have to clean both the coils and measure the readings again. If the readings are still too high, the RTU may need further troubleshooting. Recall that water vapor condenses to water on all the cold parts of the RTU. Any condensation in the RTU collects in the drain pan located below the evaporator coils. This water offers a perfect environment for the growth of mold and fungus. We then clean the drain pan and flush the pipe with water to ensure it is clean and operating normally. Finally, we close the access door of the RTU. Recall that the burner is a section of the gas furnace where air and fuel are combined and burned with a flame. It produces the heat that warms the office areas of the RTU. Locate the burner section on the RTU, and open the access door. For further inspection of the burner, we need to turn off the power supply to the RTU. We then need to find the gas supply line that goes to the burner and close its valve. Closing the valve stops the gas supply. We can now safely inspect component without the hazard of a gas leak or fire. We have to open the burner and check it visually, whether it is clean or not, and if any rust is formed on it. Burners usually clog up with dust, dirt, and lint from the air and block gas from entering the burners. As RTUs are on the roof out in the open, these checks are essential. Recall that an economizer is a device used to reduce energy consumption. Economizers use the cool air from outside of a building to cool the circulating air inside the building. Economizer works with the help of a controller which operates the dampers, thereby controlling airflow. Recall that the heat exchangers have hot burnt gases flowing inside them, which transfer heat using coils or plates. Hot air is blown into the coils of the heat exchanger, and outside air flows over it and heats up. The blower sends the heated air to the offices and rooms. Recall that the common metering devices used in rooftop units are the thermal expansion valves, TXV, and electronic expansion valves, EEV. The TXV is used to control the amount of refrigerant released to the evaporator section. A control board is an electrical component that receives and sends all the signals through a program chip. Control boards differ from one manufacturer to another. All the sensors and actuators work as per the electrical signal sent and received by the control board. Some sensors used in an RTU are temperature sensor. It measures the temperature of heat or even cold air generated in the system. Humidity sensor. It detects and measures the amount of water vapor or moisture contained in the air. Temperature control switch. The temperature sensor sends the signal after reaching the desired state, then the control switch cuts off the unit from running. Motorized actuator. These controls the dampers are closed and open upon signals sent through the board. The economizer section consists of dampers, actuators, and controls, and these are to be inspected for better operation of RTU. The TXV is inspected by measuring the refrigerant pressure and by the amp drawn by the compressor. The conditions of TXVs are high amp drawn for fully open and less amp drawn for stuck or closed. The visual inspection for heat exchanger includes checking for any cracks, corrosion, and vibrations. The electrical components include a control board, sensors, and controls, and these are to be inspected for better connectivity across the unit.